All right, everybody, today I wanted to focus on mean value theorem and intermediate value theorem problems, the ones that have been since 2012. Just a quick scroll here. There was one in 2013. There was actually two in 2014. They skipped 2015 and 16 for some reason. 2017 had one, 2018 had one, and 2019 had one. So they show up just about every year. They're not gigantic heavy hitters. You can see these points as I'm scrolling through. It's about 2 points for a question. Okay, so they tend to be not that hard. The hardest part of the AP exam is figuring out what are they asking you to do. Okay, so what kind of a problem is it? Are they asking me to take a derivative? Are they asking me to take an integral? What are they asking me to do? But these type of problems, in general, you're going to see words like justify your answer, give a reason for your answer, explain why. When you see those words, they're usually asking for some theorem, and the most likely theorems are the mean value theorem or the intermediate value theorem. So if you see those words, think it. There's a rare case where it might not be one of those two, but it's a high probability it's going to be them. So what are the MVT and the IVT, in case you forget? There are two theorems. They both require three things. First, the function's got to be continuous on a closed interval, and it's got to be differentiable. So you're going to have to prove that before you can say you're using these theorems. Now, if you remember, if you're differentiable, you're continuous, but not vice versa. You can be continuous, but not differentiable. Think of a absolute value function. Looks like a V, right? Looks like a V. It's continuous. You can draw it without lifting your pencil, but it's not differentiable because it's got a quick slope change from the one side of the V to the other side of the V. That's hard to go backwards. So usually in these problem statements, early on, they're going to tell you that the function's differentiable. If the function's differentiable, it's going to meet the first two requirements of the MVT and the IVT. Okay? So what's an IVT problem look like? All the IVT, the intermediate value theorem means, intermediate means between two things. Okay? It's just telling you that if the function's continuous and differentiable over an interval, then if you've got some value when x equals a, this is the y value when x equals a, and some y value when x equals b, then there's going to be some x value between a and b, and they often use the letter c. They say x equals c, where the function has an intermediate value between f of a and f of b. So for instance here, if f of a is 10 and f of b is 20, and the function's continuous and differentiable, so there's no monkey business, then 12, which is a number between 10 and 20, is going to exist somewhere in that interval. So that's all the intermediate value theorem is telling you, is that an intermediate value is going to exist between the two end y values as long as the function's differentiable and continuous. MVT shows up a lot more often, mean value theorem. So again, the function's got to be continuous and differentiable over the interval. If they are, then what the mean value theorem says, that there's some x value between a and b, and again they often use the letter c, where the first derivative of the function evaluated at c, and guys, that's f prime of c, there's somewhere where f prime of c equals the slope of the secant between f of a and f of b. This is the slope of the secant. This is the value of the first derivative at c. So they're just telling you that if the mean value theorem holds, there's somewhere where the first derivative, there's some x value between a and b where the first derivative equals the slope of the secant. So here's 2013, okay? Hot water's dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time 0 to 6 is given by a differentiable function. The fact that it's differentiable tells you that it's also continuous. T is measured in minutes. Selected values of c are given in the table above. So part B of this question asks this: is there a time between 2 and 4 where the first derivative equals 2? Justify your answer. So justify your answer should make you think of a theorem. Here's the solution. C is differentiable, therefore it's continuous on the closed interval. Conditions 1 and 2 are met. Then compute the slope of the secant between 4 and 2. So it's y2 minus y1 over x2 minus x1. The slope of the secant is 2. Well, look, the slope of the secant equals the slope of the first derivative. Therefore, by the mean value theorem, there's at least one time That's what the mean value theorem guarantees. At least one. There could be more than one, but there's got to be at least one time where the first derivative equals the slope of the secant. So guys, to get full credit, you got to show conditions 1 and 2 are met. You got to show that the slope of the secant equals the value of the first derivative they're looking for. And you've got to invoke the MVT. You got to mention MVT. So this is how you get the points. You get 1 point for computing the secant, showing it's the same as the first derivative, and 1 point for talking about the MVT. So that's a typical MVT problem. Here's an IVT problem. Train runs back and forth on an east and west section of railroad track. Train's A velocity is measured in meters per minute. It's given by a differentiable. Again, guys, differentiable function. That means it's differentiable and it's continuous, where time t is measured in minutes. Selected values for the velocity are given in the table above, okay? So, part B of the problem. Do the data in the table support the conclusion that train's A velocity is negative 100 meters per minute at some time between 5 and 8? Give a reason for your answer. Again, they're asking for justification. They're asking for some kind of a theorem. So if I look, when x equals 8, it's negative 120. When x equals 5, it's 40. Negative 100 is between 40 and negative 120. So since the function is differentiable and continuous, and since negative 100 is between the y values when x equals 5 and x equals 8, the IVT guarantees that there's going to be at least one time between 5 and 8 where the value of the function equals negative 100. So again, you got to show conditions 1 and 2 are met. You got to show that the value of the function is between the end values, and then you got to invoke IVT to get full credit. So guys, here's the other ones. You can see it's kind of the same thing over and over again. This is 2014 Part B. Explain why there must be a value C between negative 1 and 1 such that the second derivative equals 0, second derivative of f. Guys, they gave you the first derivative of f, so you can use those values, the values at 0 and 5, I'm sorry, negative 1 and 1, to find what the slope is. So the slope of the secant 0, so since the mean value theorem conditions hold, there's somewhere where the second derivative is going to equal 0. 2017, very similar. 2018, they got evil. Usually, every problem you see here, they talk about, the integral from 4 to 2. So if you go up in the table and you use the 4 and the 2 data values, you get the slope of the secant equals the slope of the derivative. Here, if you use the, they're talking about negative 5 to negative 3. So if you use that data right out of the table, you get the slope of the secant equals the slope of the first derivative, or the value of the first derivative. Here, for some reason, 2018, they're asking for somewhere between 2 and 10. Here's 2, here's 10. Somewhere between 2 and 10 such that the first derivative equals 2. Well, if you try and take the derivative between 2, using the 2 and 10 values, 15 minus 1.5 over 10 minus 2 doesn't equal 2. It's like, rats. So what you actually had to do is you had to start searching the different values. Try 11 minus 6 over 7 minus 5. Keeps hunting a bit. Finally, there's a combination that worked. That was pretty evil. So again, you're differentiable there for your continuous. You find somewhere where the slope of the secant equals the first derivative. So there's a value between 3 and 5 this time. So that was kind of evil. In 2019, they got back to kind of the standard. They asked for things between 0.3 and 2.8, and if you use those values, you found the slope of the secant equals the first derivative that they were looking for. So that's it. Basically, that's what IVT and MVT problems look like. That's what you should be thinking of if you see that language. Those are the steps that you've got to follow in the solution. So there'll be some of these, I guess, in the homework, maybe tonight, and there have been over the last couple of days, and there's a high probability you could see this in the AP exam. So good luck. Take care. Don't forget to wash your hands.